Okay, so here we are at VCAA's 2021 Maths Methods, Exam 2, Section B, question 3 for this particular video. All right, so we've got a function, Q, or a relation function, could be, so Q, which is log to the base e of x squared minus 1 minus log to the base e of 1 minus x. And we need to state the maximal domain and range. All right, so the most time efficient way of us doing that is going to our calculator. This is the graphs and tables, and so putting in our functions. I've already done this previously, and now what I want to do is I want to now graph that function, and there it is. So when we have a look at this here, it looks like x equals minus 1 is an asymptote, and so we can go anything below that. So anything x less than minus 1 for our range, and our domain, well, our domain, that was for x less than minus 1. And then our range looks like it actually could be anything. So for this particular one, we need to say that our domain is x less than minus 1, and our range is are all real numbers, and there we have 2 marks. All right, find the equation of the tangent to the graph when x of q when x is equal to minus 2. So it's this here. Okay, so this again 1 mark. So we're looking at using technologies. You can do this by hand, but it will take time. So if we go to our technology, and this time I need to get out of my graphs and tables into my main. And so our calculator has a way we can work out tangent lines and also normal lines. So if we go to the interactive, a calculation is what we're going to calculate. What are we going to calculate? We're going to calculate some sort of line, and we're going to do a tan line. All right, so my expression is log to the base e of x squared minus 1. Yep, minus 1, make sure I get it right. Minus log to the base e of 1 minus x. Variable is x, and our point that we're looking at is when x is minus 2 is what we're after, and then we will go OK, and so there it is. Y equals, so we've got it there up here, negative x minus 2. So let's go back here. So find the equation. So y equals negative x minus 2. All right, then the next part. Find the equation of the line that is perpendicular to the graph of q when x is equal to negative 2 and passes through the point negative 2, 0. All right, so what do we know here is that it's perpendicular to the graph. So here we've got the tangent at x equals minus 2, and this is x equals minus 2, so we're actually looking at the normal. So they just tried to word this interestingly for you. So again, we'll go back to our calculator, and again, in our interactive and our calculation line, this time we want the norm. So our expression is the same one as before, log to the base e of x squared minus 1 minus log to the base e of 1 minus x. And the point again, it's at the same point, minus 2, and there you are. And so we're titled x plus 2 there. Here it is. So our equation then, we'll come back here, is y equals x plus 2. All right, so you could do that by hand, but that would take more time. All right, so now we can move to another function. This one's p. P is e to the negative 2x minus 2e to the negative x plus 1. Explain why p is not a one-to-one function. All right, so 1 mark, so you just got to give the reason why it's not. So there's a few different ways that you could do that. Now, one of them, if we go ahead, go forward a little bit to this one, you'll see the diagram below shows parts of P, and here it is, Px. Now, if we have a look at Px, what we can find is that if we did a horizontal line, the horizontal line would cut through twice. And so if the horizontal line cuts through twice, then it's not a one-to-one function because it fails the horizontal line test. So that would be one way that you could explain why it's not a one-to-one function, is that it fails the horizontal line test. Okay, so there's other things that you could do to explain that. All right, so in fact, it's a many-to-one function because many x values could possibly give you the same y value. All right, next it says find our the gradient of the tangent at x equals a. All right, so our gradient of our tangent, so our gradient is p dashed x, and so you can get your calculator to differentiate that for you if you wished. And if you get your calculator to do that, it's probably pretty quick to do it anyway, but if you do get your calculator to do that, it will give you something like 2e to the x minus 2, and then you've got an e to the minus 2x. All right, and so we want to know what the gradient is at x equals a, and so at x equals a, that gradient, just need to put a in there, so it's 2e to the a minus 2, and then e to the minus 2a. All right, so there we are for part D. Now, there's also a factor of 2 that can come out, e to the a minus 1, e to the minus 2a. All right, so there's part D. So now we're moving on to part E, which we've already kind of, well, I used that graph. All right, before. Now it says the diagram below shows parts of the graph of P. Yep, and the line y equals x plus 2. All right, line y equals x plus 2 and the tangent of graph P at point A intersect with an acute angle of theta between them. All right, so between this line and the tangent, wherever that tangent is, you've got theta. Now, that angle could be measured this way, or it could be measured this way. So when we do that, what I'm going to do is change my pen colour here for the moment. change my pen colour and let's go for a red one. So I could have a tangent. All right, let's see how we go with this freehand line. We could have a tangent going down this way, where this angle here is in theta. Now in part E, they're talking about theta being 60. All right, so we could have that. Or we could have, let me use another colour, let's go green. Or we could have one tangent that goes like so, where this angle in here is 60 degrees. All right, so there's two possible tangents for us. Now the other thing that we know is that this angle down in here, all right, so it's y equals x plus 1, so the gradient there is 1. And remember, of course, that then means that that angle with that x-axis, it's 45 degrees. So this angle in here with those horrible dots, right, that one there is 45 degrees. All right, so let's have a look. Find the values for A, which theta equals 60, give your answers. So they intersect at x equals A. So that's the line and the tangent that are intersecting. Right, so we're looking for the 2 points, one there and one there. So we're looking for those, excuse me, those particular things. Excuse me. All right, so looks like there are two possibilities then. So for this one here, the red one, we've got an angle all the way around there. Now, remember there's 45 there, so it's 45 here. So this red one that's up here, we've got one angle, I'll call it alpha. That's 45 plus 60. So that's 105 degrees. But then we've got another one down in here. All right, at this point there. We've got another, and so what, excuse me, what we need to know is, again, an angle, and that would be the angle all the way around into here. And so that angle across here, that one all the way around into there. All right. Now, this bit in here is 180 minus 60, which is 120. So this angle all the way around in here that we were looking at, so all the way around in here, and I'll call that beta, is 45 plus 120, which is 165 degrees. All right. So why have I done that with the gradients? Well, I've done that with the gradients because back here we worked out what the gradient of the tangent was. So this is the gradient of the tangent here. And the gradient of the tangent, of course, is related to m equals tan theta. Remember, m equals tan theta or tan alpha, whichever you want to do. All right. That's what, oops, that's what I said here. So that's how I've come up with this 45 degrees, essentially using this. All right, so we've got two options. So our gradient, which is our derivative, is either equal to tan 105, that's when it's this situation, or our derivative is, which is the gradient, is the tan of 165. All right, so, and as I said in the previous previous part, we found out what that gradient was. Here it is. And so what we know is that we know that 2 bracket e to the a minus 1 bracket e to the minus 2a is equal to tan 105 degrees. We then get our calculator out. Now make sure this is 105 degrees. This is all talking about degrees here. Degrees, so make sure you set your calculator in degrees and use the solve function in your calculator. And for this one, you'll find that a equals, and 2 decimal places, a equals negative 0.67. And for the one over here, this one here, we've got 2 e to the a minus 1, e to the minus 2a equals tan 165. That's for this one. And then we would then figure out what a is, and the a for that one is negative 0.11. All right, so touches here. A is where the tangent touches that px. All right, so there's our 2 answers to 2 decimal places. All right, so I didn't show you how to do that solve function on a calculator. Do that, ask your teacher if you need help with that. So F, find the x-coordinate of the point of intersection. So the x-coordinate of the point of intersection and the line y equals x plus 2 of the graph of P, and hence find the area bounded by the graph of P, the x-axis, both the 3 decimal places. All right, so where is, first of all, the intersection? So we're wanting the intersection of the line y equals x plus 2 and the graph of P. So that would then be when x plus 2 is equal to either minus 2x minus 2e to the minus x plus 1. And then we would both correct to 3 decimal places. We need to use our calculator and solve that. And so our calculator says that occurs when x is equal to negative 0.0750 to 3 decimal places. All right, so solving that on your calculator, 3 decimal places, make sure you round it off correctly. All right, so that's the line x equals, so we know where that is. And so now, this is here, now we need to split this into 2 parts. Now, between minus 2 and this a that we've just, this point that we've just found, x value, negative 0.750, all we need to worry about is the what's underneath the line y equals x plus 2. And then from there to 0, all we need to worry about is what's under this line P. All right, because when you read it, it says find the x-coordinate, found that, point of intersection, find the area bounded by that, and the x-axis. All right, so our area then is between minus 2 and minus 0.750, and that's just under the y equals x plus 2 graph. And then the other part goes from the minus 0.750 to 0, and that's just under the P function, which is this one I'm writing down. All right, and we'll get our calculator to do all of that. I'm not going to do all of that by hand. And we get our calculator to do that, and then we get 1.038 correct to 3 decimal places. All right, so there's that particular question, and that's the end of that question. For the area, for mine, given that it talks about area, I would probably personally always put square units because it's asking for an area, and it always has some units squared. In this particular case, we don't have specific units, so that's why I've just said square units.